Gregory does sound like he can be tough, you know? I'm Gregory. Oh, don't mess with that guy. Alright, I got this. The stream's back up. We're going to get started here in just a moment. Oh man, I don't know about you guys, but I'm pretty tired now. It'd be nice if... No, I don't know if I can just call it, but yeah. I'm gonna think most people would probably vote to call it, but we should cover this last content. I guess if everyone just got up and left, I mean, you know, what could I do then? Yeah, there would be the one student who'd be like, look, what do we got to do to get you out the door? I know, it'd be terrible. So we're going to have to find the scabs in the room, right? Who are going to stick around and force me to stay. Okay, so it's 12:45, and as usual on Saturday, half the people won't be back for another 10 minutes, but that's okay. We're going to go ahead and get started anyway. So we have this little app right here, Express Library. This is what you're going to be building. Basically, it allows you to add books to the library. You're going to be able to add by book name, author, genre, and the total page count, right? So, Cowboys, the novel, author, some cowboy, genre, biography, and pages, let's just say it's 50,000. We really like cowboys, so once you have some books, I've already created some other books, you'll be able to go to this all books list and see all of the books. You could add a little formatting so it's, you know, legible here, but anyway, you want to list them all, the name of the book, the author, the genre, and the pages. Then there will be long books. You can decide what you consider a long book. So 573,892 pages is probably a long book, I'd guess. 500 pages, you may consider that a long book. I don't know, I don't read a whole lot of like fiction books, so I have no idea what long is in fiction. This one is 35 pages, so it's probably a short book. And then you can search for books. So say I want to find all the Western novels in here. Here's one Tom's Book by Tom Bookman. Is a Western. If I want to have the fantasy novels, I can search, look at all the fantasy novels. Author search. I can search for books by Carson Howard. Book search. I can search for Carson's second book. Right? So basic functionality, but a lot of different options for sure. So different types of searches, the ability to create books, the ability obviously to delete books, as you saw right down there. So I'll search again. I'll pull up the fantasy books. I will be able to delete a book, and then it should be gone. If I go to short books, it's no longer there. All of this you're going to do with Sequelize, of course. So this is activity number 5, Sequelize Library. You're going to be building this out, finishing it up, and using Sequelize to do it. So that is your task. You've got 25 minutes or so to do it, and then we'll go over it.
So in the models where it has like this cool steam filter, that's the table right there. Yeah. Yeah, and like instead of doing your boyfriend or anything like that, you can just drop that. I'm trying to
All right. How's everyone doing? Medium? Medium's a fair answer. 2? Oh, you're guessing already what I'm going to ask you. Okay. This is a pretty big one, huh? Pretty big activity. There's a lot to do. I can't imagine everyone finished. It's pretty tough, but why don't we go over it, and you can ask me any questions you might have. Let's see. Let me pull up the code. Okay, so again, we have this book app. We can add books, delete books, search for books in all different ways. The books have to have an author, a name, a genre, and the number of pages. And then we got to use Sequelize, right? So first things first, you always want to have a schema defined. Well, the schema SQL file, so you can create the database. You don't need a schema SQL file. You could just create the database in MySQL Workbench. That's fine, but you need the database created first before you do anything. So your first step should be that. Once we do that, we can start with the connection again. This hasn't changed much from the other examples we've seen. We just give the database name, your login information, info about MySQL. So you could have copied this from one of the other examples and changed the database name if you wanted to just quickly do it, right? And I recommend you do that for a while until we start generating the config information, which we're actually going to show next. So any questions on the config, getting things kind of bootstrapped or ready to go? I did forget one step, and that was before anything, you need to make sure that you have Sequelize and MySQL 2 installed, right? So, if they're not defined in the package JSON, you'll have to go ahead and do the install Sequelize and MySQL 2, not 3, right? Get that going. We're going to have Express, all that fun stuff. Okay, so we've got our config, we've got everything installed. Let's go ahead and look at how we can build our model for our book. So we're going to need to have Sequelize itself required in this file because we need to access some of the properties of Sequelize, like the data types and stuff. We also need our connection because our connection is how we connect to the database and create our new table. And then we're going to go ahead and define our new book table. So again, I've been renaming these to connection to make it a little bit easier to see what's going on. One case difference in the names is kind of hard to notice sometimes, so I don't particularly like it. And this does represent our Sequelize connection. It is Sequelize, sure, but it's just a connection. Anyway, from our connection we can call define. We can go ahead and define the table name. We'll just call it book, which means it'll probably be turned into books in our database. And from there we can define the different properties of our books. So again, our books need a title, an author, a genre, and the pages. We don't have to do anything special. These are not null. We should expect all of these values to exist on each book. If you wanted one of them to be nullable, you could. You could maybe make the author nullable, or the, I don't know. I mean, out of a book, what of these can be nullable, right? They all exist for every type of book. So, that was a good one. So, think about when you're defining your schema and you're kind of like defining the tables, think about the properties of the thing you're trying to store. Sometimes, you know, you might have stuff that's nullable, but think about the attributes of that property for a user. Is it possible for them not to have a first name? No, not really. However, you know, your system could allow them not to have a first name, but think about it in terms of the user. They probably have a name.
What about in a case where, like, they might not have that information?
You don't know your first name?
Well, I'm saying, like, for a database, they might not be able to access one page on the book.
Right. In that case, you know, you have to think about how your users are going to use the system. So the attributes is the easy way, but really that'll come down to usability. You might find that users don't know and they might start complaining. Can you really guess all these things up front? No, you can't. So you can be safe and make them nullable if you'd like, but that can cause a lot of headache for you. So I always recommend be as strict as possible on your schema up front, and then as you're testing and verifying how users will use it, then you can kind of change those things. So it's really a hard question to answer without knowing how people are going to use the system, what kind of data is available, you know. So it's a good question, but it's not one I can give you a concrete answer to, right? Yep.
All right, I got stupid questions.
Okay.
If you were to put, say you're putting a database like mice.
Okay.
With the type mice, would it be or a mouse? Would it be mouses or would it switch to mice?
That's a good question. It depends on if Sequelize has the language parsing to be able to do it. Try it. Some database tools like this, some ORMs do have that kind of sophisticated parsing for the individual languages, right? Some of them will be like, oh, this is a moose. What do we put? I have no idea, you know? Moose. Or moosin? Yeah, so some of them know that, but I think for the most part, the pluralized stuff is going to be really simple. So if it doesn't know, like, oh, it should be IES or just S or something, it might not do anything. So you'd have to try with mouse to see what it would do. That's a good question. Or you could just put mice and do the freeze table name thing, right? And that way you can guarantee it'll be correct. All right, so we have the title, author, genre. All three of those are going to be strings, of course. And then we have our book pages. We can make that one an integer because it's just going to be a number. Once we've defined our book model, we just call sync, book sync. Oh, okay. I will repeat. Once we've defined our book model, we can go ahead and call book sync to create the database create the table the first time. And then our books table should exist, and we can export the model for use in our API routes. So any questions on the model, building the model, anything else? We had a couple good questions. Is there anything else you guys want to clarify here before we move on? Okay, let's look at our API routes where we're going to use this book model. This is where we actually consume it. So there's a few simple ones. The easiest one is we want to get all the books. We just have an API/all route that's just a get. We call book.findAll off the SQLize model, and we just return all of our results as JSON. There we go. We have all of the books. That's the easiest one. That's as easy as it gets. Now we got to start getting into using the SQLize API a little bit more. So we want to get a specific book. So this is where we're searching by book title, for instance. We can have a /API with a book parameter, right? As a get. It might even be better to do something like that. But this book parameter is here, and it's not optional, it's required. So we can just go ahead and find all books where the title equals that book parameter that we're passing into the request. Now this is an exact match. If you wanted an inexact or like a contains match, you'd have to figure out how to do that using a like or something. I don't know what they call it in SQLize, but it'd be a like in MySQL. Yeah, question?
The final, is that going to be defined in our code, or is that just a predefined?
That's part of the SQLize library. So when you build that model, it gets a findAll function. After you run your findAll with your where clause, you go ahead and get results, and you can return all of those. So if there happens to be multiple books with the same title, you get both of them. So now we're going to search by genre. Similar, API/genre. This one actually has a prefix here for the genre path, and then we have a required genre parameter here. So again, very similar to the last one, we're searching by book. Now we're just doing that exact match on genre. So anything that has that exact genre will be returned. We'll just return our results as JSON. Again, we're going to do the same thing, but this time with author. So an author route takes in an author, and it'll just match the book on the author. Exactly the same as the last two we saw, just different property. So now we can define long books with pages that we consider, whatever page number we consider to be a long book. 150 pages, 200, 300, whatever you consider to be a long book. That's kind of up to you. But create an API endpoint for it. It doesn't need a parameter because we're just going to statically define this, right? So we're just going to say internally in our code that this is the number for a long book, right? We don't need to take it in as a parameter because we're not letting the user decide that. But you could if you wanted to. We're going to do another book find all, then we're going to do where, but now this time instead of just matching the property to a specific value, we have to be a little bit more sophisticated. So we want to say where the page is, and then we have this $GTE, greater than or equal to 150. That's what that means. $GTE. They use the $sign to specify to SQLize that it's an operator. That's just how they do it. A lot of things do it. Mongo will do that. We'll see in the future. So if the page count, if that number of pages on that record is greater than or equal to 150, we're going to consider it a long book and return it. We're also ordering by the pages, descending, which means we're going to have the longest book first in our list, because descending sort on a number is largest to smallest. A traditional ascending sort on number is smallest to largest. So we're going to have the longest book first. We're going to return that list. Boom. We've got our long books. Short books, going to be effectively the same query, except we have a less than equal to. Instead of the GTE, LTE, So for every that's interesting that it's greater than equal and less than equal, because that means that books that are 150 pages will show up in both. So this should probably be less than, or less than equal, and the other one should be greater than.
For the greater than, you just said more than 150, but then they put greater than equal to 150.
Okay, so greater than 150, we should change it to that. Oops. Change it to that. So $GT greater than, $LTE less than 150. So 150 pages or below is a short book. Greater than 150 pages is a long book. Again, we're going to order by pages, and we're going to sort ascending. So we're going to get the shortest book first, and then return our results. Okay. Next one, we want to create a new book. We have a post/API/new. You can go ahead and do any console logs if you'd like, just to see what the data looks like that's coming in. We take our model we call create, and we pass in a representation of that row of that new record as a JavaScript object, right? So we have all the defined properties, title, author, genre, pages. They come directly from the request body. And then if it's good, we can just go ahead and send back the properly stored results. Last but not least, we have our delete. It's a delete, app.delete. We have to search by book ID. Okay, so an ID will be generated for each new record. We'll go ahead and pass that into this endpoint. And we'll just call book.destroy on the model. So how would you know this? You'd have to look for the docs to find out how to delete something. And then you just pass in, this is a query, kind of like our find alls. So where the ID equals that ID we passed in. You could do where title, where author, genre, if you want to do bulk deletes and stuff like that. But we're just deleting off ID, and then after the then, when it's successful, we call resend, and we're good to go. Okay. So, searching for all. Here's our JavaScript to do it. We have a jQuery get to the API/all. We're going to get some books back. We're going to loop over the array, and for each item in the array, we're going to create a new div. We're going to add a class to it, give it some nice attributes to store the ID, right? We're going to append it to the well section for the books, and then we're going to just create the new book and append it with jQuery by accessing the individual book properties. Nothing too crazy there. Adding, we have an add button with the book form. We're going to go ahead and create the book based off of the elements in the HTML page. Just grab them with jQuery, right? And we're going to call a post to the API/new. When the new book is successful, then we're good to go. We've saved the book. The long is going to work the same as the all, except we're calling to the API books long. Short is going to work the same way, except we're calling to the API books short. So you have three functions here. You can wrap in one function that just takes a different route, for instance. And then the view, when you click the search buttons and stuff. So the general search button is going to take the book you're searching, grab that value with jQuery, and call the API, the first API route, right? There's the empty one, and append the book title that you're looking for. And if a book's come back, it's going to call this render books function. Author search is going to do the same thing effectively, except it's going to grab the information from the author search input, and it's going to make the request to the API/author. Genre search, same thing, from the genre search input to the API/genre input that we saw. And then render books, it's going to make sure that there are books in the list, right? And it's just going to go ahead and grab their information and render them with jQuery. And also add a delete button it's going to add the delete handler to the delete button that we are creating. Boom. So that when we hit delete, it'll make a delete call with Ajax to the API/book endpoint, passing the ID from the book. If we delete, we're good to go. It'll be gone. We'll move it from the list. We'll Slack out the solution. We got to move forward. Anyone have any quick questions on this? And anything we just saw? I know this one was really quite in-depth. There was a lot going on. We'll Slack out the solution so you can take a look at it in your own time. I definitely recommend you do that because there's a lot of good stuff there. Okay. So the last thing we're going to cover today is the Sequelize CLI. So what we've been doing today with our Sequelize is creating a connection, creating all the models, doing a whole bunch of work to get everything ready. But you don't necessarily have to do all of that yourself. You can use the Sequelize CLI. Now we're going to be using it in a very limited capacity. It can do a whole lot. It can do migrations, it can create models, it can do all kinds of things. We're really only going to use it today to initialize a new project with Sequelize and get everything ready. So I'm going to show you how we do that, and then I'll go over the code a little bit. So in activity number 6 in the unsolved folder, we have just a real basic package.json and a server.js and nothing else. And in here, we just have a dependency on Express. So the first thing we want to do before we use the Sequelize CLI is install it globally. So you're going to do an npm install-g Sequelize CLI. Go ahead and install it. And it installs it. What was that? No, because it's global. The -g means it's global, which means it's installed on your machine for your user. You can use it anywhere. The reason why we're doing that with this one, we don't have to. You can install every package locally, but this is a tool that you're going to be using to initialize new Sequelize projects. So it's an okay one to make global. You could also just make it a developer dependency on all of your packages if you want, instead of dealing with it globally. So if you wanted to do that, if you did want it global, you could do... you can install it, but instead of -g, you do -D, and that'll change this package JSON to have a dev dependency on the Sequelize CLI. This means it's still localized to this project, but it's not going to be installed with all of your other packages and like Heroku and stuff. So to use it, you'll type Sequelize after it's been installed, but you'll notice if I use it now, it says unable to resolve Sequelize package in my directory. That is because it only works if you have Sequelize as a dependency that's been installed already on your project. So we have to do npm install Sequelize. Might as well npm install MySQL2 as well. Said as well twice. I hate it when you do that. So we have Sequelize MySQL2 installed, and then we have the Sequelize CLI installed either globally or dev dependency. Again, it's kind of your preference. Now, if we type Sequelize in the command line, you get this big long list of stuff you can do. Obviously, there's a ton of things you can do. You can check out the docs on the Sequelize CLI, and I'll go ahead and Slack those out for you. Later, feel free to read those. What we're really going to do in this class to start is just Sequelize init. So you type Sequelize and then init, kind of like npm init and all that. And it'll create a whole bunch of stuff for you. You see my package, my directory just changed significantly. There's a seeders folder which has nothing in it, migrations folder which has nothing in it. Seeders would be, you know, seeding the database. You create a database and you want either fake data or you want initial data or something. You could create them there. Migrations would be I have created a database, but I'm adding new fields to tables, or I'm changing table structure, moving things around, you could create migration scripts with Sequelize that would automatically move the data in a safe way so you don't lose anything when you make those changes. So for instance, say you wanted to do a sync force, but you didn't want to lose all that data, you would instead do a migration and have the migration make those changes, right? But we're not going to get into that right now. The important thing is it creates this config folder, which has a config JSON. And the config JSON is predefined for you. You can change it to point to whatever. You can change the database name to point to our new database that we're going to create. You know, whatever you need to do to make it work. But it gives you the layout, which is nice, in this config JSON file, which is a lot nicer too than the weird Sequelize kind of like setup thing that we had to do before with the connections. It's just a nice JSON file. And where is that consumed? Under your models folder, we have an index.js, and we'll go through this. This crazy file is generated for you, and what this does is allow you to use Sequelize, and it'll automatically like create this database object that allows you to use your models. And in here, you'll notice that it requires a bunch of stuff, but most importantly, it requires the config that was created. So that's how Sequelize is going to generate its connection information for you. So let's take a look at this file, because this file's got a lot going on. It's a very confusing file. It's not super important you know exactly what's going on in here because we're generating it, right? You never have to change this file, which is really, really nice. So first of all, it brings in FS, our file system. It brings in path for path helpers. It brings in Sequelize, and then it does this: path base name underscore file name. So underscore file name is like underscore dir name. The dir name tells us what directory we are in, what directory this file is in. This file is in the models folder under all of those other folders, right? File name tells you the name of the file we are in. So this gives me index.js in the models folder, in the unsolved folder, in the whatever, right? Gives you the full file path. Path.basename returns just the file's name. It does not return the folders or anything like that. It's just the file's name. So in this case, base name is going to equal index.js. Right here, we are assigning a default environment that we are in, right? So this is very similar to that port stuff we were doing with Heroku, process.m.port, or 3000 or 8080 or whatever we chose, right? Same thing with this node_env. So if we're in development mode, say we're testing changes, we have special rules for development mode, you could do something like this and say, if we don't specify an environment, we're in development, and when we have a release version, maybe you could specify node_env equals production in the command line or something, or on the machine, and it would automatically assign production to this instead, so that you could have other rules, optimization rules or whatever. It's not too important now to know about that stuff. Sequelize is doing it for us. We're always just going to be in development mode in this class. We might go over it later with React, but we don't need it right now. And then we're loading up that config, so it's just doing an absolute path basically. It's requiring the dir name and then going up one and grabbing the config JSON from the config folder and passing in the env we are in. So in this case development, it's grabbing the development object, right? So this is the config we're using by default in Sequelize. So if you change any of them, change this one. You can change these if you want. You don't really need to, but change this one. And then it creates this empty object called db. Notice it's using the const like I was talking about earlier, because none of these are going to change. When you require something, you should always require it as a const. There's a little hint for you. So it needs to create the Sequelize. It's going to check if the config we loaded up has this use env variable parameter. It doesn't by default. Don't worry about that. It's going to create this config, so it's going to load the config database, username, password, and then pass in that config from that development config. Again, this one. So now we've loaded the Sequelize connection. This is how it builds it. Nice. connections created. It's going to take the file system. It's going to read the directory we are in, __dir_name, to find all of the files that exist in this directory. Right now it's just one, but I'll show you what it looks like when we have a model. It's going to filter the files. So what does this do? This check makes sure that the file name is not dot or dot dot. Because sometimes you'll get those. Or dot something, even. Dot get ignore. Dot get attributes. Dot environment. Whatever. Those are usually special files that are meant for some form of configuration, and we don't want them. We don't want any of that stuff, right? So if it's not one of those, and the file name does not equal base name, remember base name is index.js, so the file name is not this file, and the file name slice -3 equals JS, and the file is a JavaScript file. So if it is not a special file, starts with a dot, not this file, and ends in .js, it's a good file, we can use it. We should assume it's a model. For each of, that's going to do it for each. So for all of the files it just found, we're going to loop over every single one. We're going to grab the file. We're going to call the Sequelize import, which is a special function that takes that file name and loads it up. And what that's going to give us is a model. We're going to add that model to the DB object we've defined up here by name. After we've got all the files, we're going to go ahead and loop through them again, and we're going to associate the database with them. This is basically so Sequelize can say this is the database with this model, so we don't get messed up with anything. And then we can just add some extra parameters to this DB object and export it. This file is not important for you to understand. I wanted to go through it with you because it looks very confusing. It's not that confusing. There's just a lot going on. It's a lot of setup that's just done for you. You could write it yourself if you wanted, but why would we? Now we can just initialize it. So that's all well and good. We've all done this. It's great. But what does it look like to use a model when we generate this Sequelize config? Well, if we look over here, this is an example of what the model looks like now in this new format. You have this function that takes in Sequelize and the data types and allows you to define a model, and you just return the model. You're going to be generating this by hand at first, okay? So you should get used to how this looks. We might use the Sequelize model generator later. You're welcome to play with it at home and see if you can get it to generate some nice models for you. I've never used it personally. I just know how to initialize some stuff and work with it that way, because that's all we really want to do in this class. So this is slightly different. We don't have to bring in the connection ourselves, but instead we're exporting a function that will return our model when it's generated. So this should look pretty familiar at this point. The only difference being we have this function now as opposed to just module.exports equals user, right? But otherwise it looks fairly similar to what we were doing before. And you can define all the same things on this define that you could in the other version we were doing as well. Now my server.js, if I wanted to go ahead and use that, I can just import this DB from the models folder. So notice that I'm just requiring the models folder and not a special file. Right? That's different. That's because if you have something called index.js, it automatically requires that. It's the default file that it brings in when you require a folder. So it's equivalent to that. They are functionally equivalent, which I don't really like. People kind of abuse this, but it's nice in this case because it basically when you have a bunch of models, you'll get all of them with one require, right? You'll just get this DB object that has all of the models. So we want to create a user, for instance, or say we want to find all users. We could do db.user.findAll.then and then here you could do like console.log found users.length So again, we're going to go over more how to use this DB object in the next class. The important thing to take from this exercise is really just that you can use this SQLize CLI to initialize a bunch of this stuff. You don't really need to know what it does yet. We'll get into that. But we're going to be using it, so the SQLize CLI is very important for the rest of this week. Any questions on the CLI? Any of this stuff? Yeah?
So, I tried, because I know I will eventually forget to, let's say if I put a in the machine, I know I will eventually probably forget to make this a goal and install later. So, for future proofing myself, I decided to try to put on the dependency, so if I ever look back, looks like I need it. But for whatever reason, you decided not to work. I don't know if I have it installed properly.
If you install it as a dev dependency, when you reference it, you need to reference it like this. You need to reference it directly from the node modules.bin folder because it's installed as a package in there. So when you do it globally, it's like a command line tool. When you do it locally through the dev dependencies, it is a tool directly installed in node modules. That's why it can't find it. So it is a little bit more cumbersome to use, but we don't use it that often, so. Or, if you don't want to do that, you can try this. If it's installed as a dev dependency, you should be able to get to it from script SQLize. And you should be able to do something like that, and that should work. So if I go in here, npm run SQLize. Ah, dang, it didn't work. Well, you can definitely do this, though. Right? So you can take away that. You can do npm run SQLize. Why is it not like that? I have it in here. Oh, I'm in the wrong folder. That is unsolved. I'm in unsolved. That is why. So the first one might have worked. So I install as a dev dependency. Alright. So basically what I did is I just put it right here in this SQLize, right? The path to it. That way I can just do npm run and the name of the script in that script section. And it's equivalent to running it. So that's your alternative if you want it to be a dev dependency. Now remember, we only use the SQLize command line really for us in the initialization of your project. So if you don't have it on your new machine, does it really matter? Are you initializing the project again? Probably not, right? So is it that big of a deal? No, it really depends on what you're looking for, though. It's not a bad idea to put it in the dev dependencies. I probably would. But that's also because I hate installing things globally. It happens. Any other questions? Okay, so for this week's homework, you're going to be taking the last week's homework and adding SQLize to it. That's it. So the instructions will be in your in the homework folder on GitLab. When you decide to get to it, it's basically just take that burger maker and add SQLize. That's the whole homework. So yeah, you guys are good to go. Nothing else.
So